Today we're going to be talking about mixed expressions and complex fractions. So this is an example of a mixed expression. Okay, so I have 2 plus 4 over x minus 1. Really, you can look at this as 2 over 1. So if I look at that again, I have 2 over 1 plus 4 over x minus 1. What I need to do is I need to combine those two terms. That's what we're doing. Okay? Well, this has an x minus 1 in the denominator. I need that x minus 1 in this denominator. So I multiply by that x minus 1. So I have 2 x minus 1 over x minus 1 plus 4 over x minus 1. And so I have a 2x minus a 2 over x minus 1 plus a 4 over an x minus 1. And now I can write those under the same denominator as 2x minus 2 plus 4. And then I have a 2x plus 2 over an x minus 1. And then I'm going to factor out a 2. There's a reason I paused, because I thought that I might be able to cancel stuff, but nope. So this is writing, basically you're just combining terms. Okay, so that's what we're doing there, is we're combining those terms. Let's look at how we simplify complex fractions. If you remember back to middle school, you have 2/3 divided by 5/8. So that's 2/3 times by the reciprocal of the second one, 8 over 5. And then you multiply across. 16 over 15. Nothing to cancel, so I don't even worry. So that's what you need to remember here. Okay? Is you're going to have a lot of now polynomials under division signs, and you're going to have to just remember this is what we did in an earlier section. So just remember that. That's all we did, and we mastered that. Okay. So I have a to the 5th b over c squared divided by, I sometimes like to make that divided by bar really obnoxious so that you know it's there, divided by a b to the 4th c to the 4th. Now remember, in that dividing section we did change the multiplication and flip. And then now we cancel, okay? So I'm going to start canceling with my a's. A to the 5th and a cancel, and that becomes an a to the 4th. B's, that becomes a 1, that becomes a b to the 3rd. And then c cancels, that becomes a 1, that becomes a c squared. So then we simplify, and that's our answer. Okay, so that's all you have to remember, is to flip whatever in your denominator. And the hard part is if I go back and erase this, is figuring out like where that big division symbol is. Okay, so you might want to have to like circle one fraction and circle the other fraction so that you can see the two fractions. That might help you. I don't know. I just came up with that. Okay, so this one. A plus 7 over 4. Okay, so write that out. A plus 7 over 4. That's my first division symbol. And then I changed to the next one. I apologize on that. Divided by, now, divided by a squared minus 49 over 10. So now, I just write this as a plus 7 over 4, multiply, flip my denominator, and then I factor a squared minus 49, that's a difference of two squares, So now we cancel. A plus 7's cancel. 4 and 10 each cancel by 2. So now multiply across. Remember, when I cancel things, sometimes they're 1. If they're the same exact thing, I multiply across, I get a 5. Multiply across, and I get a 2. Okay, this one. This one is challenging because we first have to simplify that numerator. I have to simplify this into one fraction. So I have to get that to be basically one term. That's what I did in the first example. So I have b essentially over 1 plus 2 over b plus 3. If I multiply by a b plus 3 over a b plus 3, because this denominator had a b plus 3, this one needed it. So I have a b times a b plus 3 over a b plus 3, because b plus 3 times 1 is b plus 3. Okay, so that's what's on top. So now I have this. I have b squared plus 3b plus 2 over b plus 3 divided by b minus 4. Well, that b minus 4 is really over 1. It's really over 1 there. So I really have b squared plus 3b plus 2 over b plus 3 times by the reciprocal now we factor and cancel. I'm going to do that in blue. So I have a b plus 2, a b plus a 1 over a b plus 3 times by 1 over a b minus a 4. And so that equals, nothing cancels. I was hoping something would cancel. So I just multiply across. And that's what I get. Okay, our last example. Again, it might be helpful for you to maybe highlight. Okay, I have one fraction there. So I have c squared minus 4c plus 3 divided by c squared plus 9c plus 14 divided by c squared minus 9 over c plus 2. Now, I'm going to try and do a couple things at one time here. I'm going to factor. Actually, no, I'm not. I thought I was going to. I don't want to get too far ahead of myself and go too fast. So I'm going to multiply and flip the second one. Okay, now we factor. C, two things that multiply to be a positive 3, but add to be a negative 4. C minus 3. C minus 1. And then two things that multiply to be a 14 and add to be a 9. C minus 2. C minus 7. I don't know why I did minus there. Plus, you know how I knew I was wrong? Is I looked at what this numerator was. And I was like, ooh, C plus 2. Ooh, I probably should have a C plus 2 on the bottom there. These are just tricks that mathematicians like to do. The bottom of this second one is a difference of squares. So now I start canceling. C plus 3. Oh no. I can't cancel anything else? Or C minus 3? I'm shocked I can't cancel anything else. Oh, that really surprises me. I'm just double checking my math here real quick. Yep, my math looks right. Okay, so I have a c minus 1, c plus 9, all over a c plus 2, times by a c plus 7, times by a c plus 3. Okay, and that is my video on complex fractions.